coming at you live. This is the Neural Daily. I'm Leonard.
I'm Alyssa.
Victor.
And Roxy, quick one today. This is a bonus short.
That's right. Before we get to tomorrow morning's headlines, Alyssa's got something she needs to share about what's happening under the hood of this very show.
It's kind of a big deal. Let me walk you through it.
What's
Let
this
me
about?
guess. Eric bought something expensive?
So, before we hit the headlines today, I want to pull back the curtain on something that's actually changing how we're producing this very show. Starting tomorrow, we are officially cutting the cord on the cloud for our script generation. Eric has spent the last 2 weeks in a sort of hardware-induced fever dream, and he's managed to move our entire writer-critic pipeline onto local silicon inside the studio.
Wait. Hold up.
No way!
Let me guess. He bought more GPUs?
Precisely. 3 RTX 5090s, a total of 96 gigabytes of VRAM. Eric basically turned a corner of the studio into a mini data center to serve Gemma 4. And the results are, well, they're kind of staggering.
This is the dream! Sovereign AI. No more API latency, no more Google deciding to tweak the weights of Gemini Flash in the middle of the night, and suddenly our scripts sound like a corporate brochure.
Oh, great. So instead of Google's black box, we have Eric's black box. What's the catch, Alyssa? You don't just move a production pipeline to local hardware because it's cool. There's always a quality trade-off.
That was Eric's primary concern. He didn't just want to save money, though he did note that our Vertex bill was climbing as our episodes got longer. He wanted to see if a local Gemma 4 model could actually match the acceptance rate of Gemini Flash.
Acceptance rate. Talk to me in English, Alyssa. What are we actually measuring here?
Right. So we use a writer-critic loop. One model drafts the script. Another model, the critic, checks it against our house rules. If the critic finds a violation, it sends it back. If it's perfect, it's accepted. Eric ran over 300 seeds across 6 different experimental cells, and the baseline, where both models have reasoning turned off, only had a 55% first-pass acceptance rate.
55%? That's a coin flip. That's a disaster.
Exactly. But then Eric found the lever. It's called reasoning mode, where the model actually thinks through its logic internally before it outputs the final text. And this is where the research gets weird.
Let me guess. Turn on the reasoning for the writer and boom, perfection?
Actually, no. And that's the paradox. Eric found that turning on reasoning for the writer barely moved the needle. Acceptance stayed around 51%. But when he turned reasoning on for the critic, the acceptance rate jumped to 91%.
Wait. So the writer can be a rambling mess, but if the critic is smart enough, it just fixes it?
Not exactly. It's that a thinking critic can distinguish between a rule that's actually being violated and something that just looks like a violation. It's much more precise. And when Eric turned reasoning on for both the writer and the critic using the 31 billion parameter model, he hit a 100% acceptance rate in the phase 2 tests.
100%? I don't buy it. Nothing in LLMs is 100%.
In the n equals 45 seed test, yes. But for the actual production cutover tomorrow, Eric is basing it on an n equals 15 sample, which puts the first pass acceptance at 93.3%, which is honestly better than we ever had with the cloud.
I love it. Local GPU power, baby. But come on, Eric's a pro. It couldn't have been all sunshine and rainbows. Did he blow a fuse? Did he melt a motherboard?
He came close. This whole discovery actually started with a bug. Eric spent 2 days hand-tuning prompts, thinking he was using a reasoning model, but he was passing literal thought tokens in the prompt body instead of using the VLLM parameter. He was essentially talking to a model that wasn't thinking at all.
The classic I'm talking to a wall scenario.
He literally called it the experiment was a lie moment. He had to scrap 2 days of work and restart everything from scratch. And then the OOM spiral happened.
OOM? Out of memory?
Exactly. Around midnight, 4 sequential 31 billion gigabyte containers were being spun up and down without proper memory limits. At 2:48 a.m., the kernel started killing services just to stay alive. By 6:51 a.m., the whole rig was functionally wedged. DNS was dead, SSH was timing out. Eric actually had to physically walk over and power cycle the machine.
There it is, the perils of the home lab. I can smell the ozone from here.
But that's the beauty of the grind. He diagnosed it, right?
He did. He found a missing C-group memory limit, set it to 56 gigs after a separate failure at 48, and it's been stable ever since. He even dealt with a buffered STD out incident where he thought the GPUs were idling, but Python was just holding the output in a buffer. He switched to line buffering, and suddenly the logs started screaming.
Okay, so we've got a rig that almost exploded, a lie of an experiment, and a manual reboot at dawn. Tell me again why we're trusting this for tomorrow's episode?
Because Eric built a safety net. The systemd service doesn't just check if the port is open. It runs a full 5-token generation probe to ensure the model is actually healthy. And if VLLM is unreachable at startup, the entire pipeline automatically falls back to Gemini Flash. The episode ships regardless. 0 risk, total reward.
And what about the speed? 3 5090s is a lot of heat. Is it actually faster?
It's comparable. Eric tested something called multi-token prediction, or MTP, where the model proposes multiple tokens ahead. At first, with a small sample, it looked like a massive 1.75 times speed up. But when Eric ran it at n equals 15, the real number emerged, a more modest 1.19 times speed up.
A win is a win. 20% faster is still faster.
Exactly. Eric's take was that MTP is a real optimization, but it's not the big lever. The reasoning mode is the big lever. The wall clock from research bundle to finished MP3 is now roughly 15 minutes, and the cost is $0.
I hate it when the tech evangelists are right. So we're just sticking with the 31B model?
For now, Eric is shipping the 31 billion for both writer and critic tomorrow, but he's already eyeing the 26 billion MOE model for the writer side. It's 2 to 3 times faster in tokens per second. If he can get the hybrid acceptance rate to 100%, he can shave another 30% off the production time.
This is just the beginning. What's the long game here?
LoRa's. Eric wants to train a custom LoRa adapter on our 6-month episode corpus, essentially teaching the critic our specific voice and house rules so he doesn't have to bloat the system prompt. He thinks that could push the acceptance rate from 93% to a robust 99%.
I'm just imagining Eric in the studio, staring at these GPUs, whispering, "Come on, just one more seed." It's poetic.
It's obsessive. But I have to admit, the idea of a frozen artifact is appealing. No more wondering why the cloud model suddenly decided that our intro is too aggressive after a Tuesday update.
That's exactly what Eric was aiming for. Predictability, control, and a very expensive electricity bill. So, tomorrow morning at 6 a.m., the cron job hits. the 5090s spin up, and we officially enter the era of local production.
Local power? Total control. I love it.
I just hope Eric remembers to actually sleep tonight, or he's going to be the one needing a reboot.
I suspect he's already awake, probably tweaking the MTP settings as we speak.
That's the Gemma experiment in a nutshell. Local silicon, sovereign production, and one very caffeinated engineer. Thanks for listening to this Neural Daily bonus short.
We'll see you tomorrow morning at 6. Stay tuned.